Welcome, Algebra students. We're going to use this video for Thursday and Friday's lesson for this last couple days before we go on our fall break. Specifically, we're going to look at the slope-intercept form of a linear equation. And the slope-intercept form looks like this: y equals mx plus b. Go ahead and raise your hands at this time if you have seen this before. My fault. There's nobody in the room because we're still doing online digital learning. This is wearing me out. I'm sure it's wearing you guys out too. Okay, so jokes aside, let's talk this through. So this letter M represents the slope, okay, which makes sense. It's the slope-intercept form. So something else needs to represent one of our intercepts. Remember, the intercept is the point at which our function crosses one of our axes. So this is actually going to be the y value of the y-intercept. So we're looking specifically at the y-intercept. And this is just going to be the y value of the y-intercept. Okay, so for example, let's talk through some skills that we need to be able to do. One, we need to be able to graph if given the slope and intercept, or if given a function. So if we had y equals 3x plus 7, so let's practice this several times. Okay, let me draw my axes. Those are my x and y axes. Okay, so if it says 3x plus 7, remember, this is our y value of our intercept. So we're always going to start with a point. So as long as we can graph a point, we should be able to understand how to graph the line, knowing that we have the slope as well, right? Because if you start with a point and you know what the slope is, you can always calculate rise over run to find any point thereafter on that line. That's not the equation for this line, but that's an example of just saying, hey, if we knew the point that it started at and we knew the slope, so we could create rise over runs, then we would be able to draw the graph of that line. So what we're going to do every single time is we are going to plot the y-intercept. That is step number 1. Okay, so the y-intercept is 7, or sorry, the y value of the y-intercept is 7. So 1, 2, 3, 4, 5, 6, 7. We're going to plot our coordinate there. Okay? From there, we're going to plot another point. Okay, so plot another point using the slope. Specifically, keep in mind that should be rise over run. Okay? Right now, we just have a whole number. Well, remember, we can take anything and divide it by 1. So that's really 3 over 1. And what that represents is our rise is 3 and our run is 1. Okay? Run being the positive x direction and rise being the, in this case, it's going up 3. So it is a positive y direction. Okay? Let me go ahead and move some of this stuff over just to give myself a little bit more space. Okay? So I'm rising 3 units. 1, 2, 3. Okay? And I'm going to run over 1. So I need to go over 1, up 3. And then I'm just going to keep plotting more and more points. So over 1 more. And if you notice, we should be going up 3 over 1, up 3 over 1. It should be that same constant rate of change. Now, why do I say that? This is a linear function, right? We're talking about the slope-intercept form of a linear equation, or linear function. Probably should have said that. That's okay. Meaning it is the shape of a line, right? Y equals mx plus b is our slope-intercept form. It's the equation of a line. We're graphing it, and this is an example. I don't actually need this, but if you notice, it's going up and over the same rate every time, and that is our rate of change, specifically our slope, right? We talked about rate of change last unit. This is our rate at which it changes, Okay, the function rises 3 for every 1. Looks like I gridded all that. That's okay. I'll redraw that. We said 3x plus 7. And keep in mind, it also could be written like this. F of x equals 3x plus 7. So the exact same function, except now we're using function notation instead of y. Okay? But again, we're plotting the y-intercept and then plotting another point using rise over run. So let's practice this a few times. Let's go with negative x plus 9. Go ahead and graph that now. Press pause if you need to give yourself some time, and then unpause it when you've graphed it and you're ready to check your answer with mine. Okay, so step number 1, go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This right here has a coefficient. I know that it doesn't look like it, but there's a coefficient of -1 there multiplying to the x. Coefficients are numeric values that multiply to variables. Okay, so here we have a numeric value of -1 that is multiplying to that x. So in reality, even though it says -x, you should be able to pull out of that, the slope is -1, meaning -1 is our rise. Another way of saying this is down 1 over 1, always talking about to the right. Okay, which makes sense. Down 1 over 1. Okay, and we should have a point right there. And again, down 1 over 1 again. Should have another point right there. So on and so forth. Because it always has a constant rate of change. Okay, no matter where we go, the rate of change should always be the same because it's a line. That's one of the definitions of a line, is that it's the set of all points that are connected from a function that has a constant rate of change. All right. Ooh. All right, let's try another one. F of x equals -3/2 x plus 2. Okay. Press pause, practice graphing that, and then unpause, and we're back. So once again, start with the plus 2. Okay. Put a point there. A lot of people think that fractions for slope make this a harder problem. I actually think it's even easier because now you know what the rise component is as well as the run. It's very easy to see that. Rise, -3, means it goes down 3 spaces. So it's going down 3. 1, 2, 3. Run 2 means it's going over 2 spaces. And we should have that point right there. So down 3 over 2. Hopefully your drawings are a little better than mine, but thankfully I can just grab and pull, etc., move, right? And if you notice, from there down 3 over 2 would get us to the next point. It's always a constant rate of change. Okay? Very straightforward. All right, let's try another one. This time, I'm going to give you a graph, okay? Now you're really going to hate me. Boom, because even when I draw something poorly, I can just rotate it and it looks a little better. Okay, now I want you to come up with the equation for this. Okay, so now I'm going to do a couple practice problems where I give you the picture of the graph and you have to come up with the equation for the graph. All right? Press pause if you need to. Boom, here's the picture of the graph. So let's talk through the two things that we need to identify. Okay, the two things we need to identify, one would be the y-intercept, and the other would be the slope. Once we have those, then we can write the equation of this function. Okay, the equation of this linear function or line. Right? Well, here has a y-intercept of 0, 1, right? Y-intercept is a point, it's an ordered pair coordinate, that's the reason I did that. We care about this, which is the y value of the y-intercept, okay? So we would start with the equation y equals mx plus b, that's what we're starting with. And we already know what the b value is. It's the height of 1 where it crosses our y-axis. Hopefully this is helpful. So substituting in for b, the value of 1. Okay. Now we want to find the slope. Okay. That's the second item we were trying to find. So we're looking at rise over run. Sorry, I gotta stretch. It was a big day today in the gym, so my back is hurting. I timed this little break from math perfectly because I would have been annoyed if that bell would have come over what I was saying, if it was actually important. All right, rise over run. So down 2, right? And count it, 1, 2, 3, 4, 5. Rise, run of 5. It ran 5. It rose down 2, so negative 2. So our official equation is y equals negative 2/5 x plus 1. Okay? Let's practice another one of those. Okay, go ahead and write out what the equation of this function is now. Press pause when you need to, and you should be back. All right? Once again, we want the y-intercept. The y-intercept is 0, 3. We only care about, so y equals mx plus b. We only care about the b value of the y-intercept. So that guy's gone. All right. We just care about this height of 3. So the b value becomes 3. Okay, I like this problem because it's going to simplify, which is what I wanted to test you over, is can we simplify rise over run? Let's count it. It goes down 3 because it was 1, 2, 3. Boom. So negative 3 over a run of 1, 2, 3. So we would not write that the slope is negative 3 over 3. Okay? We would have to simplify that. So think about what negative 3 over 3 reduces to. That's just negative 1. And I don't actually write, so I definitely don't write negative 3 over 3x plus 3. We don't do that. I also don't write negative 1 over 1. We don't write that. That is really the same thing as negative 1. But we really don't need this 1 to be there when we know that negative x, it really means negative 1x. Okay? So we kind of keep that in mind. So this is how we would write that. Okay? Let's try one more. All right. Go ahead and press pause and write the equation down. And then unpause it, okay? So you should be back with me now. and we are going to we are going to identify what the equation is for this line. All right, so once again, it's slope-intercept form, so we start with y equals mx plus b. We need to identify what the y-intercept is. Oh, it crosses right there at the origin. Well, what is that coordinate? That coordinate is 0, 0, meaning the b value is 0. So if I put plus 0 right there, well, wait a second. Do we ever really need to write plus 0? What's 10 plus 0? 10. What's 17 plus 0? 17. What's mx plus 0? That's just mx. So because this crosses through the origin, we don't have any constants at the end. So now we know what a constant is. A constant is a numeric value that doesn't attach itself to a variable, and that numeric value of 0, right? Right, it's its own term that disappears in this case. Okay, so we have y equals mx. So now we just have to count rise. So that's 1, run, 3. Rise, run. So we've got y equals 1/3 x. Up 1 over 3. Up 1 over 3. We could keep following that pattern to see the rest of this linear equations graph. Okay? We got one more of these for you guys, just because I think that it's really essential that you know what to do in a scenario like this. Okay, now if we were supposed to write the equation of this line, we no longer have the y-intercept already identified. So there's two ways we can do this. I'm going to show you kind of the less mathematically algebraic way. We can calculate the slope is up 1 over 2. Hopefully you see what I'm doing there. It's up 1 over 2. Okay. Up 1 over 2. Rewind if you need to. That tells us what our m value is, correct? So we can already identify that. Okay. And now what we can do is we can count backwards to try to find the y-intercept. So we can go, just like we can go left 2, down 1, we can go left 2 more, down 1, takes us to this height. Then we can go left 2 more, down 1, takes us to this height. So -1, 2, 3. Okay, so we get y equals 1/2 x minus 3. That is one way of doing this, where we worked backwards to count down to where that y-intercept should have been. The other way that we could have done this, so press pause if you're comfortable with that. Okay. The other way that we could have done this problem, so I'm going to get all of this extra slop out of the way. And this is where we're going to start getting algebraic. Okay? The other way that we could have done this is we know the m already. We want to find the b value, meaning that is a variable we wish we could solve for. But we also have two other unknown ideas, x and y, except we have coordinates. We can choose either of these two coordinates. I'll go with this one. Okay, just because random, I just chose that one. But that coordinate is 4, -1. Well, guess what that coordinate is? It is an ordered pair x and y, meaning you could take x of 4 and plug it in right there. Take y being -1, plug it in right there, and then all you have that's left over is this to solve for. So let's try that. Okay. let's plug in -1 for y. We still have the 1/2. Now for x, let's plug in 4, because that's the x value. And we're looking for b. Now we just have one variable that's unknown. Solving this out, -1 equals 1/2 of 4 is 2. 2 plus b. Oh. Subtract 2. B equals -3. Guess what? That's the answer we already said. Right? We already said y equaled 1/2 x minus 3. We just got that answer a second way. And guess what? We actually could have used the other point as well. Yeah, I know, I'm making you go through a lot right now. But I think it's essential to get your minds a little bit closer to my mind, where I have a strong understanding of this. Okay? So let us look now at this coordinate. So what I'm saying is we could have also used that coordinate. Didn't need to use this one, could have just randomly chosen this one. 1, 2, 3, 4, 5, 6, comma, 0. Okay? So watch. Plug in 0 for y, plug in 6 for x. 0 equals 1/2 of 6 is 3. Move this 3 over, -3 equals same answer. See? We get the same answer either way. All right? The idea of plugging in numbers is actually where we're going to go next with this concept. Okay? This is the next scenario we're getting into. Okay? Oh, and in fact, there's even one more way that we could have done it. But it's okay. I will show you that in a second. So, write the equation of the line that has a slope of 7 and y-intercept of 0, -3. Okay, go ahead and write that equation at this time. Okay. Again, we always start with y equals mx plus b. Oh, students, right now, write in the chat box the name of these shoes to prove that you are actually watching the video. These are the Air Jordan 11 Retro Legend Blue. 2014 edition. Now I know if you're watching or not. Okay, here we go. All I've got to do is substitute in the slope and substitute in our y-intercept value. So y equals slope of 7 times x minus 3. Boom. Very straightforward. Okay? Another problem. Watch this. Slope of, I don't know, we'll go with -6 and a y-intercept of 0, 0. Go ahead and write that in. Okay, you should have gotten y equals -6x, nothing else. You don't need to write plus 0, you shouldn't have. The answer is just y equals -6x. Okay? All right, let's go with a slope of -1/7 and a y-intercept of 0.4. Okay, press pause, and then go ahead and unpause it. Okay, y equals -1/7 x plus 4. All right, so far so good. I'm going to change it ever so slightly. Slope of 2 and it goes through 3, 5. Notice now, I do not give you the y-intercept. Because I don't give you the y-intercept, all right? Because I do not give you the y-intercept, you cannot just write your answer as 2x plus, oh, that's the y value, 5. No, that's wrong. This is not the y value of the y-intercept. This is the y value of some other point. If I were to graph this, here's 3, 5. That's just some other point. And we know the slope of the line through there. We are missing the y-intercept. Hopefully this drawing makes sense. It helps you out. We are going to solve this the same way that we did on that last example on this page, where we plug in the slope, and then we plug this in for x and this in for y. Right? And so what we've really got is 5 for y equals 2 times 3 plus the b value. And we are looking for this b value. So we end up with 5 equals 6 plus b. Move this over by subtraction. B equals -1. And now we can go back and substitute that in for b. Plus, we'll just say -1. All right, at this time, I'm going to ask that you rewind this video and rewatch this problem again, because I really think it's important for you to see what I just did in slow motion, and then you take notes on it. Okay? Really essential. Let's try it again. Write the equation of the line that has a slope of 2. So we'll do a new problem now. It goes through the point, let's say, the slope of -1/2 and goes through the point 4, -3. Okay? Press pause, work that out, and now you should be back. Okay? We're starting with y equals mx plus b. We've got y equals -1/2 x plus b. That's all we know. I have substituted in the slope. Remember, this is your x, this is your y. And so we have -3 equals -1/2 times the x value of 4 plus our b value. -3 equals -1/2 times 4 is -2 plus b. Add 2 to each side. -1 equals b. Now that we know that b is -1, go back up to our equation and substitute that in. We said -1. Boom. Okay. Final skill I want to show you. Okay, let me show you this last skill. Write the equation of the line that passes through the points 2, 1, and 4, 5. All right, this problem is a notch more difficult because now I don't even have the slope. All right, so step number 1 is going to be to find the slope. 5 minus 1 over 4 minus 2 takes me to 4 divided by 2, which is 2. So now that we know the slope equals 2, and I'm going fast because I know it's a long video, but you guys can rewind it, pause it, do what you need to. Now that we know the slope is 2, we can get rid of either of these points. I already showed you on this problem, either point we used from here would have gotten us the same answer. So either point would work. I'm just going to use this for my x and y. Please recall we're using y equals mx plus b. Okay. So we've got 5 equals 2 for the slope times 4 for the x plus the b value. 5 equals 8 plus b. B equals -3. Okay. And now we know our answer. Y equals slope of 2 times x minus 3 for our b value. Boom, there we go. I would, if I were you, watch this problem through several times. Okay, this is a great example. Okay, that covers a lot of what you need to know regarding linear equations or linear functions, linear equations in slope-intercept form. Okay, hopefully this has helped you. What you've learned how to do is, let's go back to that slide. What you've learned how to do is graph it. You have also learned how to write the equation from a graph and also from a situation. That's like a word problem where I gave you just now the point and, the slope and the intercept, or I gave you the slope and another point, or I gave you the slope, I gave you 2 points. So that would be like a summary of what we just worked on, okay? Some topics that were not, there's a couple topics that were not in this video. We didn't deal with anything regarding horizontal or vertical lines, and we didn't deal with anything regarding perpendicular or parallel lines. So I'm going to get into that next in my next video. So you might need to watch part 2. We'll call this Algebra 1 Slope Intercept Form Part 1. Have a great day, y'all.